Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
The third problem is it's a very easy problem. It just says that if x follows standard normal, then expectation of x to the power 7 is 109 and half. So it's a very easy problem actually, as you already might know that the answer is 0 obviously, because x is standard normal. It's a metric distribution about the point 0, and obviously the answer is, if you can also calculate it, but anyway, expectation of x to the power 7 is nothing but integral from minus infinity to infinity x to the power 7 into the CDF, sorry, the PDF, 1 by root 2 pi into e to the power minus x square by 2 dx, right? So as you can see, this function, this PDF fx is a even function, right? F of x is equals to f of minus x, right? It's an even function, and the this function x to the power 7, it's an odd function because minus of x to the minus x whole to the power 7 is minus of x to the power 7, right? So this entire function, this odd one, this is a odd function, and this is an even function. So the product is an odd function. So the product is, this entire thing is an odd function, and therefore expectation of this thing is actually 0, right? Or we can also see there is also a theorem. I don't know if you guys know or not, but if a distribution is symmetric about some real number alpha, suppose, and if the expectation exists, then the expectation is that value, and all odd ordered moments about that number, all ordered central moments about that number are 0. So here, since x is a standard normal distribution, it is a very symmetric distribution, right? The symmetry is about 0. So here the expectation exists and the expectation is 0, right? And therefore expectation of x to the power 7 is nothing but expectation of x minus 0 whole to the power 7. That means the same thing. The expectation of x, the seventh order central moment about the point 0. Again, it is 0, right? Because from the theorem it follows immediately. So if you know the theorem, you can just write, or right off the bat you can just answer it to be 0. The answer is 0. So also we can just find the integral. It's a very easy problem, right? I don't think it's a very hard to understand. So okay, so and then I'll be moving on to the next problem. So here the problem 4 says that x follows P7. This is Poisson 7. This just means Poisson distribution with 7. The value of the parameter is 7. So x follows Poisson 7. That is, x follows a Poisson distribution with parameter 7. The correct arrangement of the following events in increasing order of their probabilities. So there are 4 events given, 1, 2, 3, 4. So the first one is x is equals to 2. Second is x is equals to 5. Third is x is equals to 7. And the fourth is x is equals to 10. So basically what you have to do is that you have to calculate the probabilities of each of these events. Obviously that will be a number, right? And you have to arrange them in increasing order. So it is actually a difficult problem if you think in the way of that I'll be calculating each of the problem, each of the events, the probability of each of the events, and then I'll be arranging them. That's a very difficult thing, because by hand it's very difficult thing, right? And even if you use calculator in jam, that's gonna take a lot of time, right? That screen calculator. So what we're gonna do is, see, since x follows Poisson 7, so the PMF of x is nothing but e to the power minus 7 into 7 to the power x by x factorial, right? Where x is 0, 1, 2, and so on, the support of x. So let us take p of x by p of x minus 1, right? That is e to the power minus 7 into 7 to the power x by x factorial divided by e to the power minus 7 by into 7 to the power x minus 1 by x minus 1 factorial. I'm just dividing these two. So it turns out to be 7 by x. Where x, obviously x cannot take 0 because I have already taken p of x minus 1. So if I take x is equals to 0, that means p of minus x minus 1, right? So that will be a problem. X has to be at least from 1, right? So now, so p of x by p of x minus 1 is nothing but 7 by x, right? I'm basically trying to see that the order of the probabilities in the Poisson distribution. So if you have seen the graph of Poisson distribution, it's actually kind of a very positively skewed distribution, right? It has a unique mode. Not a unique mode, it depends on the value of the parameter. If the parameter is an integer, then it has two modes, and if it is not an integer, then it has a unique mode. So anyway, I'm trying to kind of calculate the mode of the distribution, and it's not very difficult to do. So p of x by p of x minus 1 is nothing but 7 by x, right? So what is this? So p of x is less than p of x minus 1. That means this ratio is less than 1 if this ratio is less than 1, right? Because this p of x where p of x minus 1 is nothing but 7 by x. So p of x is less than p of x minus 1 is same as 7 by x less than 1, which just means that x is greater than 7, right? So that means this will hold, this p of x is less than p of x minus 1 will hold if x is greater than 7. That means if x is 8, 9, 10, and so on, this thing will hold. On the other hand, p of x is equals to p of x minus 1 if 7 by x is equals to 1, right? Which means x is equals to 7. And p of x is greater than p of x minus 1 if x is less than 7. Just the, it basically this condition, this p of x and p of x minus 1, I'm conditioning this on the value of x. So for what values of x, they will be the, what's the relation among what is the relation between p of x and p of x minus 1? It depends on x. So if x, it takes the value 7, then p of x and p of x minus 1 are same. That means p of 6 and p of 7 is same value. On the other hand, if x is greater than 7, then p of x is less than p of x minus 1. And if x is less than 7, then p of x is greater than p of x minus 1. So basically, if I take on the values from 1, 0, 1, 2, so basically the order of the arrangement is this: p of 0 is less than p of 1, is less than p of 2, up to p of 6, which is equal to p of 7, mind you. This is the thing. P of 6 and p of 7 have the same value. Again, this is greater than p of 8, greater than p of 9, and so on. So basically, this function, if I were to plot the PMF of this graph, the function will have two maximum at p of at the value 6 and 7, right? And before that it was increasing, and after that it was decreasing, right? So I've kind of the mode of this function is obviously 6 and 7 both, right? This is not a unimodal function. So anyway, so since we are to find the values of the probabilities of p of, x is equals to 2, 5, 7, and 10. So since 2, 5, and 7 both, all of them lie in this thing, in this part. So p of x is equals to 2 is less than p of x is equals to 5 is less than p of x equals to 7, right? Because they all lie in this first part. That part is clear, right? So that part is clear. That means, see, one denotes this one, right? This statement, as you can see, one denotes the 1, 2, 3, and 4. So 1 denotes x equals to 2, 2 denotes 5, 3 denotes 7, and 4 denotes the statement 10. So 1 is less than 2 is less than 3, right? Okay. You have to arrange them in increasing order. That means the smallest one will be in the first, and the largest one will be the last. So 1, 2, and 3, we have got this order. But what about 4? That means, what is probability x is equals to 10? Probability x is equals to 10 is obviously, again, it is less than 7, right? It is less than probability x equals to 7 because it is decreasing here. And so we, again, this is a problem that we have to find what is the probability, where lies it, where does it lie in this relation. It is obviously less than 7, right? So it might be in between p of x, p of 5, and p of 7, or it might be in between p of 2 and p of 5, or it might be between, I mean, before p of 2, right? So we don't know that. So maybe we have to calculate at this point, you might think, but we don't have to calculate. Why? Because see, this order 1, 2, and 3 is here. See, option B. See, option A is that 1, 3, and 4. Oh, sorry, 1, 3, 2, and 4. So this option A cannot be true, because it says that 1 is less than 3 is less than 2. But right, but we have already established that 1 is less than 2 is less than 3. They are increasing. Same goes for option C and D, right? Here is also 1, 3, 4, 2, and 4 again. And here is also the same problem. Only option B contains 1, 4, 2, and 3. So 1, 2, and 3, the order in among 1, 2, and 3 are reserved, right? In option B, 1, 2, and 4. 1, 2, and 3, sorry. And the fourth option, probability x is equals to 10, lies between 1 and 2. That means p of x is equals to 2 is less than p of x is equals to 5 is less than p of x is equals to 7. So 10 lies in between 2 and 5. So it can be the possibility. So option B is the correct answer. All right. So
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MStat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.